Everybody, so like we've announced in green here, we do have a test this Thursday. We do. We just had a quiz. We're gonna have a test on Friday. We'll review on Thursday. Last class, Friday, you had time to work on this transformation assignment. If you've been missing lots of class, you know where to get it, right? In case you've been here all year and you still don't know this, Blue Bin has everything labeled with the date. So make sure you grab what you need when you're not here, right? And there's notes filled out in the Blue Bin, also on Google Classroom, also with videos like we're recording right now, right? Okay, now, we don't think about the past anymore. It's currently basketball and hockey season, right? So we got to promote the Dallas Stars and the Dallas Mavericks, right? Unless you're a Spurs fan, we might be butting heads, but it's okay, right? All right, now, can you draw a dilation? I'm asking you to do something really simple. Draw a smiley face, and then show me you can shrink it, okay? So you understand similarity, because we already talked about similarity. Can you shrink a smiley face, make a smaller one, make it happy, all right? Easy. Okay, this is the concept of dilation, which we're about to do some notes on. And then, of course, hopefully you can make a bigger one, okay? We call that a stretch. These are the words that are used, especially if you're going to retake the EOC Algebra 1. You have stretches and you have shrinking. Those are the words they're going to use, okay? So we want to be familiar with these words. We are going straight into these notes. Spoiler, the big concept today is that you're multiplying by a scale factor, okay? There's one little tricky part of this, which we're going to understand here in a minute, okay? All right. So let's do it. All right, let me get my notes up here. Here we go. All right, dilation and scale factor. Okay, a dilation, by the way, hear how I say it. Dilation, not dilation. There's no dilation. Okay, a dilation is a transformation. You can underline that. We've been talking about transformations last class and the class before it. Rotation, reflection, translation. Those were the three we talked about with coordinate pairs. So if you were here, make sure you get that. Today is the fourth one, and it's dilation. Okay, so what does it do? It makes it the same shape, but a different size. You remember when we went over this last week before? The word is similarity, right? They're similar if they're the same shape, different size. Hey, what are you doing? All right, number 2, underline scale factor. Scale factor of a dilation is the number that describes the size change from the pre-image to its dilated image. Sorry, now that everyone actually has the notes, scale factor, notice how it says that it's the number that describes the size change from the pre-image to its dilated image. Underneath those words, the pre-image is the original, and the dilated image is the new image. Okay, so you have an original, and then you change it, and you got a new one. Okay, that makes sense. Original, new. Now, I'm going to make a big deal about this. Hopefully it'll help you learn this. Is everyone looking at me? Look with your eyeballs. Look at me. Everyone look. Is everyone looking at me? Okay, so look. To know scale factor, you have to know. Let me say that again. To know scale factor, you have to know. Say no. Okay. Do you understand? No. All right. Here's what I mean. Look right here. Scale factor is what over what? New over old. N over O. It's not O over N. It's N over O. N over O. You know what I'm saying? That you got to know N over O. And if you don't know, no. Are you going to get it right? No. No. All right. There you go. So everybody, got to know N over O. That's how you do scale factor. Guess what the easiest thing to get wrong is? To get it upside down. I don't want y'all to get it upside down. That's wrong. I want you to do new over the original. N over O. So off to the left here, go ahead and put N over O. This is a proper scale factor. N over O. Cool. If you can remember no, because you know what I'm saying, you'll be good. All right, let's apply N over O. Ready? That was basically what it said in number 3. We're going to do example 1. Now, look at these figures. They're similar. Same shape, different size. Let's connect the two sides that are labeled there. 8 corresponds with 5, right? If they want a scale factor, it's either going to be 8 over 5 or 5 over 8. Well, how do I know which one is correct? I got to use N over O, right? Cool. Example 1. Here we go. What is the scale factor of dilation from pentagon 1 to pentagon 2? Now look, if I go from 1 to 2, which one's the original? 1. 1. And I go to the new one, pentagon 2. So label that. Pentagon 1 is my original. Pentagon 2 is the new. So when I'm doing scale factor, I'm going to do N over O between two corresponding sides. Okay, so the new, we said, is pentagon 2, which is going to be 5, over the original, pentagon 1, is 8. 5 over 8 is my N over O scale factor. Do you see how that works? That's it. The only other thing you might have to do is reduce a fraction, but 5 over 8 is reduced. Now look at example 1, the second question, is almost the same exact question, but it says it backwards. What is the scale factor of dilation from pentagon 2 to pentagon 1? Now you tell me, if I start at pentagon 2, and I go to pentagon 1, which one's the original? 1. 2. 2. Okay, so whenever they tell you blank to blank, the first one is the original, the second one is the new one. You always start at the original and you go to the new. That's how it works. So if I'm going to do scale factor again, I'm going to do N over O. New is pentagon 1, which is 8, over the original, pentagon 2, which is 5. So N over O is 8 over 5. Reduce it if you can, but this does not reduce. Okay, are y'all getting how this works? What do you have to remember? You got to know. Say it in Spanish. No. Okay. It works in both languages. Here we go. Number 4. If the scale factor is greater than 1, if that fraction, N over O, if it equals something bigger than 1, then your figure is also going to get bigger. The better word for that is it's going to stretch. That's the mathy word, stretch. And then if the scale factor is between 0 and 1, who can tell me a number? What's a number between 0 and 1? Did you say 1.5? 0.5. Another example could be a fraction, 1/3. Okay, things that end up between 0 and 1 are going to make it smaller. The math word is going to be shrink, though. Okay, very important. So depending on your scale factor, will tell you, does it get larger or smaller, stretch or shrink. Example 2, here we go. Here we go. Example 2, under a dilation, the picture shown at the right has been reduced. Reduced. Now you tell me, if this thing has been reduced, which one's the original? It has to be the bigger one, because the new one has to be smaller. Isn't that what reduced means? It's smaller. Okay, so let's label this. The bigger one is the original. The smaller one is the new, because that's what it means to reduce. From big to small, right? Okay, so what's the scale factor? Scale factor is n over O. What do y'all think it's going to be? What over what? What over what? Okay, what's going to go on top? 12 over what? 12 over 48, okay? Because the new smaller one has a side length of 12, and that corresponds to 48, the original 48. Okay, so take that fraction, and if you can, reduce it, right? So y'all got the luxury of these yellow calculators that'll reduce it for you. What is 12 over 48 reduced to? 3/5. Nope. So if you plug it in your calculator, you should get 1/4, okay? Again, make sure you plug it in. It'll reduce it for you. Hopefully you can do that mentally, but if not, that's how you can do it with your calculator, okay? Now I know this says you can use scale factor to find a missing side length, but I would like for us to continue to rely on our proportions the way we did it, okay? So if you have an example like this, I want you to notice something. Is everyone looking at this, okay? A, B, C, D, look where they are. A, B, C, D. Now look at the bigger one. Is A in the same spot? No, now it's down here. This has been rotated counterclockwise, okay? To the left, this is a rotation. What does 12 correspond to if it's been rotated? Like if I'm going to draw my lines to connect, if it's been rotated, 12 doesn't go to 11.5 because it's been rotated. It would go down here, and down here matches the other side. So 12 is going to go to X, 4.6 is going to go to 11.5. Please look out to see if they're rotated. It's going to change your connections, which is going to change your fractions, which is going to change your answer, right? So can't we set up those two proportions, cross multiply and divide, like we did last week? Hopefully. So 12 goes to X. We're going to have 12 over X equals, and then in the same order, 4.6 goes to 11.5. That's going to be our second fraction. This should look very familiar from our first couple of assignments. And then we're going to cross multiply and divide. So 12 times 11.5 is 138. And then 4.6 times x. Whenever we have a number times a variable, it goes out front as a coefficient. 4.6x. Hey, what are you doing? Hey, what are you doing? Hey, man, use the calculators I gave you. You can't use the phone on a test. Now, last step, to get rid of that coefficient 4.6, we have to divide by 4.6. What? Sure? All right, it is 30. Got that down, you can flip it over. Almost done, see? Now, two examples and we're done. Once everyone's got this, flip it over. You got this? Who's still getting this front side? Okay, on the back, real quick. Coordinate dilation. Now, the last assignment we did was coordinates, okay? Remember? A bunch of graphs. A little packet of graphs that you were doing transformations on. So what about if it's a dilation on the coordinate plane? So remember, k is your scale factor. So here's the rule. You start off with points x comma y. You end up with points kx, ky. You're basically multiplying. That is what you're doing in a dilation. Write that down so we can do example 1 and 2 and be done. Hey. So again, k is my scale factor. You multiply x and y by k, the scale factor. On example 1, I want you to plot those points. Right? It says A, B, and C. Go ahead and plot A at 9, 6. They're both positive, so 9, 6 is to the right 9, up 6. Go ahead and put a point there. And label that A. B is negative 6, 0, so that's 6 to the left. It doesn't go up or down. That's B. C is 6, negative 3, so right 6, down 3. Put a point there. Oh, just C, my bad. And then the rulers that you grabbed on the way in, question mark, can use to make nice straight lines, right? Nice straight lines. You don't want to have these like weird squiggly lines. You want to have nice straight lines. Now, that is just the original triangle. What are we doing? It says it's dilated by a scale factor, which we just learned is multiplying 1/3. So we're going to take every x, y number and multiply it by 1/3. Okay? So we're going to take A, B, and C times 1/3. Now, you can literally type them in the calculator, times 1 divided by 3. Okay, another way to think about times 1/3 is just dividing by 3. Did y'all know that? Times 1/3 is the same thing as dividing by 3. So I'm going to take every one of these numbers and just divide them by 3 to get my new points. Okay? And I already did that earlier. You could type this in your calculator to get all these numbers. Okay? But 9 divided by 3 is 3. 6 divided by 3 is 2. Those of us who are just writing and not thinking, look, I took each number times 1/3 to get these new numbers. Same thing here. Negative 6 times 1/3, or negative 6 divided by 3 is what? Mental math. Negative 6 divided by 3. Anybody? Negative 6 divided by 3. What? Divided. How many times does 3 go into 6? 2. Okay, so negative 2. Negative 6 divided by 3 is negative 2. 0 divided by 3 is still 0. Okay, 6, negative 3. 6 divided by 3 is 2. Negative 3 divided by 3 is negative 1. Okay? I'm going to trust that y'all can actually divide numbers by 3. Put it in the calculator. Don't need it. Now, can you plot those new points and connect them? Remember, to do a transformation, I got to see it on the graph, the final points. Here we go. 3, 2, plot that point. 3 to the right, 2 up, call it A prime. Negative 2, 0, left 2, call it B prime. 2, 1 is right 2 down 1, call it C prime. And then can you connect those dots? Doesn't this new triangle look like it's 1/3 of the original? Divided by 3. Every length is 1/3 as long. Centered on the center there. Y'all ready for the last one? Everyone should have this down. The original times 1/3 is like dividing by 3 to get the new points. Plot the new points, okay? Does anyone still need this? Okay, last one, example 2. Now look, I got 2 figures. Before I can do anything with scale factor, I need to get 2 corresponding sides. let's see the length of the top of each figure. So the inner one, I'm going to count the top's length here. So from between A and B, I have 1, 2, 3, 4, 5. This is 6 units long, okay? And then A prime, B prime at the top, let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 at the top here. Now, remember, if it's from this to this, you start at the original and you go to the new. Same thing with the second question. You start at the original and you go to the new. Okay? And since we're looking for scale factor, I'm going to do new over original. Now you tell me, look right here. If A prime, if the primes are new, which number is the primes? 15 or 6? 15 has the primes on all the letters, right? So when it's new over old, it's going to be 15 over 6. And if you type it in your calculator, it does reduce to 5 over 2. Okay? And then B, you're going to do other way around. The new scale factor is new over original. A, B, C, D without the primes is 6 over the primes is 15. And obviously this one is just flipped. But when you reduce it, you should get 2 over 5. Okay? So keep those notes. Y'all have the assignment, right? Before you do that assignment, look. I turned in this homework from Thursday, Friday. That's your first thing, okay? Because you can still finish that tomorrow. The assignment for today. If you need to fix a quiz, I'll give you that opportunity today, or you can wait till tomorrow. Either way. All right, but I'm gonna let y'all get started working. So please be working. You'll have plenty to do. Here we go.